He leave procedure of room experts has discovered that, with the utilization of our new $101 billion gadget, it will take seemingly forever before that drive turns into a reality. If everything goes as arranged, the outing to Proxima B is supposed to endure almost 20 years. Sensibly, this implies it will take an extremely extensive stretch before we can affirm whether life really exists on that planet. The deep-rooted question of whether we are genuinely alone in the universe continues. The James Webb Space Telescope has uncovered some astoundingly Earth-like components in far-off pieces of the universe that bring us closer to addressing this question. Our quest for life beyond Earth has been a persevering journey throughout each human civilization, resulting in endless media reports and hypotheses about this subject. Our interest in our place in the universe and the significance of our presence has been constant, as though it's imbued in us to constantly search out a companion, regardless of how disconnected we may feel. We might be drawing nearer to the answers we have long desired, but are these answers really what we expect, or do they hold significantly more disturbing insights? Join us as we analyze the most recent revelations in the fields of galaxies and exoplanets on our journey to uncover something we may not be ready to experience. Lights from far-off scientists have uncovered what could be the most significant discovery in history. Back in 2021, when the James Webb Space Telescope was set to launch, an extremely intriguing hypothetical question was raised regarding the abilities of our future space exploration. The question was whether, eventually, our telescopes would have the ability to identify artificial lighting on another planet. For example, Proxima B, the closest exoplanet to Earth. Proxima B, found roughly 4.25 light-years away, was believed to be tidally locked, meaning it has a fixed, constantly lit side similar to our Moon. A theoretical mechanical progression on Proxima B could permit it to move power between the constantly lit sides using photovoltaic cells that harness energy from starlight. As demonstrated in a study with Mana V. Lingam as one of the creators, it was shown that the presence of large solar arrays on the planet's dayside could be identified by future telescopes. Given that the James Webb Space Telescope is more advanced than its ancestors, it opens up the possibilities for us to expand our search for artificial lighting to far-off exoplanets, such as Proxima B. In 2024, this is exactly what the JWST did. Utilizing its improved responsiveness and more extensive scope of abilities, the telescope might have identified the lights we've been looking for, potentially setting off another wave of human advancements. Let us now jump into the universe of exoplanets and explore how this discovery became possible. The James Webb Space Telescope has been instrumental in researching the secrets of Proxima B. Since time immemorial, humans have pondered the idea of the universe, our beginnings, and our future. These are normal yet significantly complicated questions that humankind has strived to answer since we became conscious creatures. Now, in the era of extraordinary technological advancement, we might wonder whether we are any closer to answering these significant questions. If you were to ask a philosopher, they could suggest that we are still at the very beginning of understanding ourselves and our place in the universe. However, if you ask an astronomer, you would almost certainly see them eagerly tell you about the latest discoveries humans have made about the universe using advanced instruments. These instruments, while not given much attention by the general public, are a clear sign of human advancement. We now have access to an abundance of cosmic data, and it's time for us to also gain a deeper understanding of the universe itself. One such effort has been led by scientists and space specialists with their work making way for the discovery of what might be artificial lighting on a far-off planet light-years away. This advancement was made possible by the James Webb Space Telescope, a development born out of humanity's tireless exploration of space to answer the eternal questions. Are we alone? Who else exists? Where do we come from? And where do we end? This infrared space science device has just begun to address these questions, but you could find yourself asking, what exactly is Proxima B? Proxima B, part of the Alpha Centauri system, is a super-Earth exoplanet that orbits an M-type star. Super-Earths may sound puzzling, but don't worry. This text will explain your questions. Super-Earths are a classification of planets that are larger than Earth but smaller than gas giants like Neptune and Uranus. These planets are quite unique, and their composition can be rocky, gaseous, or a mix of both. Their sizes can range from 2 times to several times the mass of Earth. As for Proxima B, it is a super-Earth and an exoplanet, meaning it orbits outside the solar system. The first likely evidence of an exoplanet was proposed as early as 1917, although it didn't receive much attention or approval at the time. However, the first confirmed discovery happened in 1992, which left researchers astounded. In 2003, another exoplanet, first identified in 1988, was confirmed. As of April 1, 2024, 5,653 confirmed exoplanets have been found in 4,161 planetary systems, with 896 of these systems hosting multiple planets. These astonishing planets are orbiting M-type stars, the most common type of star in the Milky Way galaxy. To understand the M-type star, one must first learn about red dwarfs. A red dwarf is the smallest type of star in the main sequence, hence the name. Red dwarfs have extremely low luminosity, making them difficult to detect. They emit very faint light and have variable brightness depending on their size and temperature. Proxima B orbits a red dwarf star that radiates around 1.6% of the Sun's total luminosity, making it much dimmer than our own Sun. In terms of visible light, the star's shine appears even fainter, radiating only about 5 to 6% of the Sun's visible light. Proxima B, located about 0.045 to 0.056 solar masses from its star, was officially discovered in 2016. You may wonder why Proxima B, alongside the myriad of stars, planets, and galaxies, is of such great interest. The reasons are numerous. First and foremost, Proxima B is the closest known exoplanet to our Sun, which makes it a critical objective for study, just 4.2 light-years away. This distance is minuscule in the vast size of the universe. Proxima B is also part of a triple star system called Alpha Centauri. Furthermore, despite its faint shine, the system is one of the brightest celestial objects visible in the night sky, second only to Sirius and Alpha Centauri A and B. Most significantly, Proxima B resides within its star's habitable zone, making it an area of great interest to scientists looking for possible life beyond Earth. This is where the James Webb Space Telescope comes in. The JWST's four main objectives are to look for light from the first stars and galaxies that formed after the Big Bang, focus on the formation and evolution of planetary systems, inspect star and planet formation, and study planetary atmospheres and potential signs of life. As the JWST continues to research exoplanets like Proxima B, we edge closer to fulfilling these grand missions, which range from identifying exoplanets to searching for extraterrestrial life. But what exactly does this mean for us, considering that humans have always been a curious species, constantly seeking out and exploring every possible facet of the universe? This mission is the reason why initiatives like SETI, Search for Extraterrestrial Intelligence, were created. SETI represents one of humanity's most ambitious tasks, to find signals from intelligent life forms. Scientists have now moved beyond listening for radio waves. SETI is also examining technological signals that could indicate the presence of an advanced civilization capable of producing such signals. The idea is that we might one day detect an exoplanet bathed in artificial light or one with large solar arrays. SETI's new frontier is to identify these technomarkers, signs of technological advancement from extraterrestrial civilizations. These efforts align with the work of the James Webb Space Telescope, as its powerful infrared capabilities could assist SETI in detecting these technomarkers. The JWST acts as a cosmic scout, identifying promising planets while searching for potential signs of intelligence. Although the search for technomarkers is fraught with challenges, space is vast, and signals can be incredibly weak. The hunt continues, driven by the hope that one day we will know that we are not the only ones in this enormous field. This new discovery by the JWST could be the first clue in this game of cosmic hide-and-seek. If the telescope has indeed detected artificial lighting on Proxima B's dark side, it could mean that an intelligent civilization exists there, capable of harnessing energy as we do. But what does this discovery, in fact, suggest? Could we have found extraterrestrial life? Are we truly alone in the universe? Or is there more to this discovery than we realize? The very nature of this discovery is both thrilling and unsettling, as it points to a future filled with vast possibilities. Let's delve into the details and explore exactly what this could mean. The implications of such a discovery are enormous and profound. If the lights detected by the James Webb Space Telescope do indeed indicate an artificial source, it would mark a monumental step forward in our understanding of the universe. It could suggest that another intelligent civilization exists, one capable of creating technology like our own. This raises numerous questions. If such a civilization exists, how advanced are they? What is their society like? Have they faced the same challenges and dilemmas that we face? The discovery would not only challenge our view of the universe but also force us to reconsider our place within it. In the search for extraterrestrial intelligence, we are confronted with a multitude of uncertainties. The universe is vast, and the distances between us and other potential civilizations are staggering. Even if there are signals out there, the challenges of detecting them are immense. The light from Proxima B, if it is indeed artificial, may be the first clue in a long journey of discovery. However, we must also acknowledge the possibility that there may be no clear answers, or that the answers we find may not be what we expect. The universe is full of mysteries, and our quest to understand it will likely never be finished. Moreover, the detection of artificial light or technomarkers on Proxima B could also lead to new technologies and methods for exploring distant planets. The search for signs of life beyond our solar system is no longer limited to theoretical discussions. It has become a tangible, concrete endeavor. The James Webb Space Telescope's ability to detect faint signals from exoplanets and its capacity to look into the infrared spectrum provides us with unique tools to explore the universe in ways we never thought possible. This technology could enable us to not only detect artificial lights but also gain insights into the atmospheres and surface conditions of distant worlds. By detecting these technomarkers, we may even be able to confirm the presence of other civilizations, an achievement that would transform our understanding of life in the universe. Nevertheless, the question remains, are we ready for such a discovery? The consequences of finding proof of intelligent life elsewhere are vast. On one hand, it would validate our suspicions and dreams of finding other creatures in the universe. On the other hand, it could also bring about existential questions and challenges that we are not prepared to face. The discovery could reshape the way we view ourselves, our place in the universe, and our relationships with each other. It might also spark debates over the ethics of interacting with other civilizations, especially if those civilizations are more technologically advanced than we are. As we continue to search for answers, one thing is clear: humanity's curiosity will not be quickly satisfied. The quest for extraterrestrial life is far from over, and the James Webb Space Telescope is helping to fuel that journey with each new discovery. We are one step closer to understanding the mysteries of the universe. Whether we find life on Proxima B or elsewhere, the very question holds significant importance for us as a species. It drives us to explore, to ask more questions, and to push the boundaries of our knowledge. Soon, as the James Webb Space Telescope continues its mission, we may uncover even more exciting discoveries about the universe and the potential for life beyond Earth.